This is Algebra 1 STAAR, Lesson 28, Writing Systems of Linear Equations. The main thing we're going to need to do is to translate English into algebra, where verbs and symbols, and so really this is not solving systems equations, it's just writing the equations. So let's go ahead and see what we can learn about this. If you can describe a problem situation in one variable, then you can find the solution to an equation that models it. If the problem situation requires two variables, then you need at least two equations to find a solution, one for each variable. Two or more linear equations, the same variables, make up a system of linear equations. So you're going to have two variables on the same coordinate plane. And writing a system of linear equations, to write a system of linear equations, begin by identifying the two variables. Then so we're going to have step one, we'll call identify the variables. We'll call that step one. Then write two equations that model the situation being described. When you're done, check that the equations are independent, meaning you cannot rewrite one equation to the other. So we have two separate equations. One thing to have is that verbs are going to be equals equal sign. Okay, so it's going to be a matter of picking out which verb. And then the numbers, and so we're going to see that. We've got to just, and you get a knack for it doing this over time. So new vocabulary, systems of linear equations, independent. Now we talked about independent, like independent and dependent variables. Time is often independent, but we're going to just go ahead on this. Example one, Sandra bought 2 apples and 4 peaches and spent $4.45. And so I said verbs are an equal sign. Here, spent is the equal. And an apple would be one variable, and a peach could be another variable. And you can just use the letters of the objects. And then on your test, they might just reduce the thing to X and Y after all. But here you have 3 apples and 3 peaches, and they tell you that you can get, they spent $4.45. So that's one equation. And you know there are 3 apples and 3 peaches, and it says, and Corinne bought 5 apples and 2 peaches and spent $4.85. And so here's another one. And again, Sandra spent. So spent's another equal sign. So here you have a system of equations. And then, to me, the hardest part is actually writing the system. After you write the system with the TI-Inspire CX calculator and other calculators, you can really solve the system pretty easily. Next, let's go on to quick check 1. Suppose you have 30 coins in your pocket that are either dimes or nickels. And so it says identify the variables in step 1. So we're going to say D is equal to dimes, and N is equal to nickels. And they are worth 2.10. So you have 30 coins in the pocket. So you have you have dimes, number of dimes, plus the number of nickels. They are equal to 30. And you know the value, you'll have, that's a typical equation. Value, you have a dime equals $0.1. Let's put a dollar symbol, 0.1. And somebody just say, oh, nickel. Nickel is equal to $0.05. You can see if you multiply this 0.1 times 10, you'll get 1. If you multiply this 0.05 times 20, since there are 20 nickels in a dollar, you get it that way. So we have D plus N equals 30, and then we have 0.1 times the number of dimes plus 0.05 times the number of nickels is equal to $2.1. And so this is going to be your system of equations right here. Okay, just writing systems. And once you write the system by using NSolve and a T-squared-CX calculator or some other thing, you can solve pretty easily. But writing the equation is the tough thing. Next, 1B, Neil is 1 year more than 3 times as old as George. So we're going to have two variables. We'll say Neil, we'll say Neil equals N, and George is equal to G for George. And so again, in our equal sign is, Neil is, so Neil, and really we're talking about their ages, right? So Neil is our equal sign, 1 year more. Well, 1 year more means 1 plus 3 times as old as George. So that'd be 3 times George's age. So there's one equation. And then the sum of their ages is 115. So we could say Neil's age plus George's age equals 115. So one of the guys is probably pretty old. And then we can solve this system of equations. And the next two lessons are going to be more involved in solving systems. This is writing systems. So next, systems of linear equations and break-even problems. Systems of linear equations can be very useful for solving real-world problems. A common problem that we solve using systems of linear equations is a break-even problem. Break-even problem situations can be described using two variables, one to represent the number of items and one to represent the cost of each item. So let's go ahead with this vocabulary tip. In a break-even problem, two processes are described by a system of equations. Then the two expressions are set equal to each other to solve. And sometimes you'll see these systems graphed like this. And you'll see, okay, here's one equation here that's graphed. Here's another equation that's graphed. And so this thing right here, where the two lines intersect, is called the system. Solution of the system. Okay, and most systems of equations will have a solution. There are a couple other situations. Okay, next we have example 2. Newsletter costs $0.25 per copy to print plus $25 to distribute. Subscription of the newsletter costs $0.5 or 50 cents. Total advertising income is $15. How many copies must be printed and sold for income to equal costs? And so what you want is an income equation and a cost relation and set those equal to each other. And so the cost is going to be 0.25n and then plus $25 to distribute, and then our revenue, our income, is going to be 0.5 times n, and the total advertising income is $15, so plus 15. And here we've written the system of equations that we essentially, by setting equally to each other, and we solve for n, we will know what our answer is for n, how many. And then if you have, again, a TH bar CX calculator, numerical solve will give you the solution to this one quite easily. Next, quick check 2. One tank containing 35 gallons is being drained at a rate of 3 gallons per minute. So we have, we'll say gallons equals G. So we have 35 gallons is being drained at 3 gallons per minute, right? The second tank contains 50 gallons, is being drained at a rate of 8 gallons per minute. And one thing you're going to have to look at here, if you have these slopes different, you're going to have a solution. Because you start out higher here and you're going down faster with this 50-gallon tank. So eventually you're going to intersect. So write a system of equations to find the time until both tanks have the same volume. So if you set these equations equal to each other, you have 35 minus 3G is equal to 50 minus 8G. And there you have a system of equations. So it's a single break-even equation. So next, 2B, it costs Karen $20 to make each of her wooden display cases and $300 to advertise it. She sells the cases for $30 each, writes system equations to show when her cost will equal her revenue. So we have cost, our cost equation is equal to, says wooden display cases. We'll say wooden display cases. We'll call display case D. D equals number of display cases. So our cost is equal to 20 times the number of display cases plus she spent $300 for advertising. And then for our revenue, okay, revenue, and sometimes you'll see people try to put sales here. Well, sales is not as good an answer because revenue is total income received. So if she sells the cases for $30 each, well, she's going to get 30 times D. So how many, a break-even equation is going to be setting cost equal revenue. So we can set that equal by putting 20D plus 300 equals 30D. And you can solve this quite easily if you subtract 20D from each side. You have 300 is equal to 30D minus 20D, which is 10D. And then if you divide by 10, we have D, or 30 is equal to D. So she's going to have to sell 30 display cases to break even on the deal. So if she sells fewer than 30 cases, she's losing money on the deal. If she sells more than 30 cases, she makes money on the deal. Okay, now STAAR practice. And we're going to go through 5 problems here. Ed buys 6 postcards and 4 souvenir magnets. And so we're going to say postcard. Oh, by the way, go ahead and pause the video, solve the problem, and restart to see if you got it right. So postcard is equal to P, and then souvenir magnets is equal to variable M. And so Ed buys 6 postcards, so that's going to be 6p plus 4 magnets, and he spent for those $16.90. And then we have Bill buys 3 postcards, so that'd be 3p plus 3 magnets, and for those he spent $10.80. And that's it. And so now we can just look at which one makes sense. Sometimes they just mix these numbers. So 6p plus 4m. We look for 6p plus 4m, could be B. Yeah, okay. That's the only place we see 6p plus 4m. And then we have 3p plus 3m equals 10.8. So B is our correct answer. Next 2. Pause the video, solve the problem, then restart to see if you got it right. Okay, Sandeep bought 4 notebooks, so we'll say notebooks equal N. And then pen equal P. And the numbers we need to worry about are these right here, 6 and 3. So we're going to have, one of our equations is going to be 6n plus 3p. And that's what Sandeep bought. Now Sandeep spent $18.9, right? And the next one, we have Tobias bought 4 notebooks and 2 pens. So 4 notebooks plus 2 pens is equal to, how much did Tobias spend? $12.6. And where do we see that? 6n plus 3p. And I'm thinking H, right? We got on F they got the cost mixed up. But H is going to be our correct answer for problem number 2. Next, 3. Okay, we have the bake sale sold pies. So we'll say pies is equal to P. And then cookies, we'll say C. So cookies equals C. So pies are $8 each. Does it say the 10 times as many cookies sold as pies? And so cost of pie is going to be equal to 8 times the number of pies, right? Cost of pies will be 8 times the number of pies. Cost of cookies is going to be 1 times the number of cookies. So 1C, which is going to be equal to C. Okay, and so we need 2 equations here. We know the total sales of these items was $108. So we have $108. So 8 times the number of pies plus the number of cookies times 1. So our cost for these total items is going to be 108. And we have 10 times as many cookies sold is pies. So our number of cookies is going to be 10 times the number of pies. And these should be our two equations here. So 8p plus c equals 108, and c equals 10p. Okay, we need with 8p, if it just had, so it could be this one, could be this one, could be this one, not going to be this one. And we're going to need 10p equals c, that's possible there. And this is 10c equals p. So we're definitely talking about answer A here. So you just have to look around carefully and put these equations together. Next, problem 4. Stop the video, see if you can solve this, and restart. See if you got the right answer. Okay, let's see. So we'll say E equals, they're talking about music files, right? E equals number of Emily's files. And then we have M is equal to number, of Meredith's files. Okay, Emily has, well, has is going to be equal sign, so Emily has equals 4 fewer. Now this is really, you might be tempted to put 4 minus, but really when you have 4 fewer, you have to put, you're going to put minus 4. So 4 fewer than twice as many files as Meredith. So we're going to have 2 times Meredith's minus 4. That's how many Emily has. And they have a combined number of 86 music files. So that would be Emily's files plus Meredith's files. They're going to be equal to 86. And these should be our two equations. The tough one is this 4 fewer thing. You got to put minus 4. I guess you could put negative 4 plus 2m and get the same thing. But here, sometimes they write these a little differently. 2m minus 4, I see that down here. That could be right. In fact, I think J is right. You have E plus M equals 86. And sometimes they put these numbers around. You can see this thing written as, if you added 4, you would say E plus 4 equals 2M. But J is our correct answer. So as long as you got to play around with these a bit. You can try to solve these, see if an answer makes sense. Now number 5, the last one of our lesson, pause the video, solve the problem, then restart and see if you got it right. Okay, car starts at 8 a.m. from town A and drives east along the highway at 60 miles per hour. Second car begins the same time from town B and drives east along the same highway at a speed of 50 miles per hour. So time can be hours, right? So time is the number of hours, and let's see, distance, to give you the letters, T stands for distance, T stands for time, excuse me, number of hours, and D stands for distance. So for car A, you have 60 times the amount of time is going to be equal to the distance. And then for the other one, the second car begins at the same time, which is 30 miles east of town A. So you're going to have 60, you have 50 in this case. 50t, and our distance, you started to the east, so 50t equals our distance minus 30, or that could be rewritten as 50t plus 30 equals our distance, either way. But just look at these things. I think what we're going to have here is this one right here. 30 equals, no, 30 plus 50d equals t. Let's see, no. Okay, 60t equals d. We know 60t equals d is going to be right. So it can't be b. And then 30 plus 50t equals d. Yeah, it's going to have to be answer choice A. So anyway, good luck. I hope this has been helpful. And then, to me, the hardest part is actually writing these things out, because once you have these written out, you can solve it pretty easily. Good luck, and thanks for viewing. Yeah.